everyone. Good evening, good morning, good afternoon, wherever you are. This is Niladri Chaudhary, CEO of Excellent Row, and also providing this service called Playground, the virtual dojo, along with Dinesh Mistry from DeepFactor. So our topic today, developer-led security starts here. Empowering engineering teams to create secure and compliant cloud-native apps. So while I was going through my daily LinkedIn posts and all, I came across this one. And what I saw is, this point is very important. A group of teenagers had several billion-dollar companies, and what they did not have was a master's degree or an experience working at FANG or 10 plus years of experience in technology or a CISSP or CISM or CISA or CISO kind of roles or certifications. But what they had was the willingness to learn and the drive to do something. Now, this is very important when we see today's scenario. This is from this healthnetsecurity.com. Their survey shows that number of C-suite citing external human error or accidental loss as the cause jumped to 53%, up from 28% in 2018, which means that majority of our vulnerabilities or things that are happening, bad things that are happening, are because of people doing mistake, people willfully sabotaging things. So it's more to do with people. And the only thing that can be taken care of is by people. And that's where we need everybody to practice DevSecOps. There is no alternative. That I'm not going through this whole thing as far as the what IBM is saying as the what is DevSecOps or all these things. You can read it, you can look at it. But what is important is to understand that we need to take care of sensitive data, proprietary information. We need to stop disruption to the regular operations. We need to take care of our organization so that it doesn't lose financially. And just at the beginning of the pandemic, one of the large IT service providers, what did they do? They had gone and they had seen that their customers' codes are wiped away from their GitHub scenario, and they paid through their nose through cryptocurrency till August 2021 and lost customers. But all of this is because we are not taking accountability of it. So as Mark Hornbeck says, and also this is what I have put in my book called Adapting to Industry Infinity, New War for IT Services, if we have to do continuous delivery, we need to have continuous security. It has to be baked into the entire delivery lifecycle. And we need to be clear that if anything bad happens, it is because of me. It is because of each one of us as a developer, as a tester, as a security expert, as an operations person, because security is not only something which needs to be done at the end of the work, after you have worked for 18, 24 months, and then somebody looks at it, or running some ad hoc tools. So if we look at it, the 5 values of DevOps, we need to look at the 5 culture of DevOps. Important. All technology teams have accountability for security. Security is everybody's job. All understand the end-to-end system and collaborate regularly to create trust. Automation helps assure security by strategic use of codifying the orchestration and automation of tasks and processes that have security vulnerabilities when done manually and where automation can enhance security practices. Security is not a constraint in the value stream. It is not slowing down the DevOps process. It has to optimize the flow, work together to improve the flow. We have to obviously measure. I was talking to Caroline Wong, she's the CTO of Cobalt.io. And she said that in her company, she has started something called SNPS, Security Net Promoter Score. We need to start looking at measuring security and finally sharing the knowledge. Why are we talking about this? Why are we talking about the DevOps principles and DevOps values in this? We need to look at the flow, increase the flow. We need to get the security feedback early in the day. We need continuous experimentation and learning to do things in a better way. And that is what you can see today, how Deepfactor helps you in helping out in achieving what we are talking about. And not only that, this is part of this particular webinar is part of a journey called Playground. This is a service provided, it's unique and not provided anywhere other than through Excellent. There is playgrounddojo.com, where we have partnered with many companies like Deepfactor, where not only you can just hear about things in webinars, but you can come on a pay-as-you-go. Our team will help you in hypothesizing the experiment and practice that, see how it works. Take that learning to your home, to your office, to your production environment, whatever you need to do, and do it on your own, right? So with this, I will not take much of a time. I will hand it over to Dinesh Mistry, who is the VP of Customer Experience in Deepfactor, the developer security platform. And from here, Dinesh will be taking you through with a short few 3-4 slides, and then he will actually show you the demo of this particular event, this particular product that they have created. It's a wonderful product, amazing. It helps you in getting 75% more vulnerabilities from your code that you have written. It helps you in getting 90% more faster because it gives you that shorter feedback loop, and it gives you your developers, your testers, that knowledge which they gather by practicing this, by using this tool. They get to learn more about it, right? So over to Dinesh. Thank you for your time to share your knowledge here.
Great, thanks, Niladri. And can I go ahead and share my screen so I'll be able to jump directly into the demo? All right, so let me start from here. Thank you for the introduction, Niladri, and thank you for inviting Deepfactor to present the Deepfactor security platform. So as you mentioned, I head up our customer experience team here at Deepfactor, and I work closely with Niladri and the team when you guys sign up for the Playground Dojo. So as Niladri's been covering here at the top of the slides, ensuring applications are built securely from the get-go is paramount, especially in this day and age as folks are shifting to the cloud. So what Deepfactor has built is a developer security platform whose goal is to really empower the developers and the engineering teams to start creating and building secure and compliant cloud native applications from the start. So we've all heard the term shift left, and that's been a big notion for the past several years. The Deepfactor security platform actually takes that a little bit further and encourages developers to inherently build secure applications as they're going through that build process. So in order for that to happen, as we're moving to the cloud, it's very important that we support cloud native based instrumentation. So the Deepfactor platform is purpose built specifically for cloud native applications. So for things like Docker, Kubernetes, etc. Though our platform does still support the legacy monolithic applications. So if you still have virtual machines or physical machines that are running applications, we certainly can help in that regard as well. And this allows us to observe basically every thread, every process, everything that's happening inside a container and a pod to inform you with what we refer to as application-aware insights. So by analyzing the behavior of the application during runtime, and when I say runtime, I should take a step back and kind of clarify. So a lot of folks think of runtime as production runtime. In our case, we're talking about as the developer is building his or her application, and it's going through the QA or the test cycles, and the application is being exercised or run, we're collecting and analyzing the behavior of the application. We're observing things like the dependencies, the operating system packages that make up that application. And then we're able to actually provide detailed stack trace alerts to help pinpoint the developer to the actual vulnerable code that the alert was triggered for. And this helps with prioritizing remediation. And finally, we need to make sure that it's a unified developer security experience. So to that end, the platform integrates with all the existing CI/CD toolchains, which enables the developer to have a security pipeline that is quite simple to use. And it's useful for both the developers as well as the developer ops teams within engineering organizations. So what makes Deepfactor unique? As I mentioned, it's our ability to seamlessly collect information from within all your application components. So we're observing every system call, every library interaction that's running within the application itself. And we do this without requiring any code changes. So when we talk to developers, the last thing that they want to do is add additional lines of code into their application that they're not responsible for. With Deepfactor, there's no code changes that are required. There's no agents, no sidecars, or even kernel modifications. It just seamlessly integrates. And as I jump into the demo, I'll show you how easy that is. We built the platform to be language agnostic because we understand that there's many different programming languages, and certain applications could actually be a mix. So you may have an application, as you can see on the screenshot here, this particular application is made up of both Java, C, as well as Python components. We're agnostic to any cloud, so you could be in any of the cloud providers, you could be on-premise, we will work pretty much anywhere. And we are CI/CD ready. So let's talk about the insights that we collect. So the first thing is what we refer to as a supply chain visibility. And this is a dynamic software bill of materials. So you've probably heard of tools that allow you to collect all the dependencies and operating system packages that make up an application. With Deepfactor, alongside of the operating system packages and dependencies, we're also collecting additional items such as the licensing information. What are the network ports that this application is connecting to? And also additional metrics around what those application and network interactions are happening. And I'll show you some of that here in the demo. Secondly, we provide a full application artifact scanning. Again, this is done at the application level, which means that all the alerts that we generate are very specific to the components that make up that application. So this includes a comprehensive dependency scan, a complete container scan, and then we prioritize the alerts that we find with actual runtime usage. So what I mean by that is you may have a container that has several hundred vulnerabilities, but only a certain handful of those vulnerabilities are actually being used by your application. A great example of this is the recent Log4j or Log4j announcement, where folks had a lot of Java applications and developers, as a matter of practice, were importing the logging dependency, but may not have been using it. And they needed a quick way to prioritize which applications they needed to remediate first. So with a Deepfactor platform, not only would we help identify all the applications that contained that vulnerability, but we would prioritize the applications that actually leveraged the vulnerable dependency to help prioritize remediation efforts. And then this is the secret sauce for Deepfactor, right? The runtime behavior and code risks. So as I mentioned earlier, we're monitoring all the behavior that the application is exhibiting. And this includes, again, very detailed metrics around process, memory, file system. So things from file open, file read, file write, as well as down to the code itself. So if your application is using a function to make an API call and it's using a random number generator, for example, we're able to analyze that code in runtime to see if it's securely coded. And if we identify that it's not only do we alert against that potential vulnerability, but we provide very detailed remediation steps. And I'll give you an example of that in the demonstration here. And we also bundle in what we refer to as an observability enriched DAST scanner. So this will help identify any of the OWASP top 10 vulnerabilities that may exist in web applications, but we refer to it as enhanced because there's a couple of additional items that we provide. First is the fact that it's integrated directly into the platform, which means that it can be executed during the CI run of the application itself. Secondly, we provide an enhanced coverage capability because since we're monitoring the application from the inside out, we're able to observe any additional URIs that the scanner may not be able to crawl when it's doing a black box approach, for example, scanning from the outside in. And then finally, we map all these security alerts back to compliance violations. So today we support PCI DSS version 3.2, NIST 853, and SOC 2 Type 2. So, and we are going to be supporting additional compliance frameworks here in the future. But what this really helps is giving you the ability to get ahead of any compliance requirements that you may be facing. So again, this is very specific to the application. Lots of tools are doing infrastructure-based compliance assessments, but Deepfactor will give you the very specific application layer compliance assessment. So I think this is the final slide before I'll jump into the demo, but it'll become a lot more apparent how easy it is to use Deepfactor. But at a very high level, there's really 4 steps. So the first is to integrate into the CI pipeline. So as the developer pushes the code into an SCM, such as Git, Deepfactor integrates itself into the application and starts observing the application. Any types of alerts that are generated are then sent to the developer, and this notification could happen in terms of Slack notifications. Oops, sorry. It could happen in terms of Slack notifications, in terms of automatic creations of Jira tickets, for example, or you could simply consume the alerts from the portal itself. And then once the developer fixes and verifies that the vulnerability has been fixed, we provide a command line tool. So this command line tool, DFCTL, is very similar to cloud native command line tools such as kubectl. This allows for the developer to do a quick assessment of their fix on their development environment before pushing it through the entire CI pipeline again. So once you've remediated a fix and before you commit that fix, you can very quickly check on the command line to see if that has actually been fixed indeed. And then in terms of deploying this into Kubernetes, I'll actually show you how we do this, but it's very, very simple. So it's a simple help command. We use an admission webhook that essentially says, hey, monitor a particular namespace or a set of pods based on an annotation, and then instrument Deepfactor around those. So the developer doesn't have to do much. Once the Helm chart or the webhook has been deployed, any continuous push into that cluster will allow the application to be continually monitored by Deepfactor. So with that, I think I'll jump into the demo and give you an overview of how this actually looks in real life.
Hi, Dinesh.
Yep, sorry. Yes.
Just before you jump, because there is a question I thought might as well ask that in the thing. Will Deepfactor scan identify in the nested jars if there is any Log4j related vulnerabilities, for example, in the source code?
Yes, that's actually a very, very good question. Yes, so we scan the entire file system. We identify, any place that dependency could exist. So we're not just looking at a package.json in case of NPM. We'll be able to identify if that dependency exists anywhere on the file system.
Thanks. Please go ahead.
It's a great question.
Later on saw Andrew had already replied also.
Oh, great. Yep, no worries. So the Deepfactor platform is very simple to use. So when you first sign into the interface, you're presented with a list of applications. So here I signed into our demo platform, and you can see I've got 4 applications that have been deployed. Bank of Anthos and a couple of language-specific applications. What I'm going to do is I'm going to show you how easy it actually is to deploy an application into DeepFactor. So as I mentioned earlier, all I've done to set this demo up is, yes.
Your video is off.
Oh, sorry. Let me turn that off. Oh, is that better?
Yes.
Okay, sorry about that. So all I've done to set this demo up is I have deployed that webhook, and I've told it to monitor for 2 namespaces. So I've asked it to look for anything that gets spun up inside of the development namespace or the production namespace. So here we can see that I've got a bunch of applications in the development namespace. So what I'm going to do now is I'm going to actually deploy another copy of this Bank of Anthos application into the production namespace. So if I switch over to my command line tool, I'm just doing a very simple kubectl apply. The manifest files exist inside of this folder. They have not been altered, so these would just be typically created by the DevOps team or by the developer, so there's no manipulation of these that are required. And I'm simply saying, hey, go ahead and deploy this into the namespace production. So as soon as I do that, it'll go ahead and start deploying those containers. So if I take a look over here, you can see that they're starting to spin up and they're starting to come online. If I then switch back into the portal and then I give this a quick refresh, you'll see that it's automatically registered itself into the DeepFactor portal. And we can see here that they're now starting to show up inside of the production namespace. So without any effort from the developer, we've simply been able to just deploy the application into the Kubernetes cluster, and DeepFactor has started monitoring these applications. So from here, you can continually drill down to investigate what is happening or the security posture of the application. So if I expand this Bank of Anthos application, we start getting some more details. So here we can see that it was deployed into Kubernetes, it was deployed into the development namespace, and how those 154 security alerts that we've identified were distributed. So here we can see 15 of the alerts were tied to specific runtime-based alerts. So this means the behavior and the risk violations that we described earlier. We've got 94 that were tied to vulnerable dependencies, 11 to the operating system packages, and then 34 were discovered by the DAS scanner. And then we can also see here in the middle of the screen how these alerts are mapped back to the compliance. So out of the 154 alerts that were generated, 82 would have been in violation of PCI DSS, 15 for SOC 2 Type 2, and 76 for NIST. And then we also give you a quick snapshot of what the bill of materials looks like. So in this particular case, this was a banking application that was made up of several components. In fact, it was made up of 6 components. This is the aggregated total of all the dependencies and all the operating system packages that were deployed to make up this application. And then from here, we can drill even further down into what we refer to as the application-specific view. So here you start to get a lot more detailed information. So across those 15 runtime alerts, they were distributed across these types of events. So 3 were related to file system, 6 to process, and 6 related to the node. And then in terms of dependencies, so here we can see that we generated 56 alerts, but we noticed that the application itself was actually made up of varying programming languages. So it had some Java components, it had some Node components, as well as some Python components. And this is the distribution of those alerts. So in total, 699 dependencies, of which 56 were vulnerable, and we actually generated 56 alerts. So what this actually means is that all 56 vulnerable dependencies that were identified were being used by the application because they generated an alert. And this becomes a little bit more apparent in terms of how we prioritize based on usage when we look at the operating system packages. So here we have a little over 1,000 packages that have been loaded by the application, of which 334 were vulnerable, but only 30 of those libraries that were bundled within the OS packages were actually used. And in this case, it only generated 11 alerts. And this is because some of these vulnerable packages were not used by the application itself. So again, in terms of remediation, we know we want to tackle or remediate the vulnerable operating system packages that were being used by this application. If we look at the lower left here, we can see the results of our dynamic application security testing scan. So we identify all the web services that the application is actually exposing. So here we can see the top 5 web services and the distribution of how those alerts were generated. And we'll double click into some of these to show you what the alerts look like here in a second. As I mentioned earlier, it's not really just a software bill of materials, it's actually a dynamic bill of materials, because we've also identified the language stack. So you can see again here, the total number of dependencies, but we also monitor and keep an eye on things like the network listening ports. So what ports are being opened up by my application? And then what web services are actually being exposed? And then finally here, you can see how those map back to the compliance alerts. Now, Audrey, I see some questions in the chat. Do you want me to pause here to see if there's any questions, or should I continue?
Yes, why not?
Maybe
even though Andrew has answered it, but for the sake of everybody, let us have the answer in the audio also. So is DeepFactor solution deployed in K8s nodes, as Jimin said, as LSM, or is it bundled into container image?
Yeah, so it's a full, kind of microservice-driven architecture. So in terms of deployment, we're actually flexible. So it can be deployed into any of those configurations that have been described. The portal itself can actually be deployed as an OVA as well. So the portal side has a lot of flexibility. And then, we talked a little bit about the instrumentation of applications. In this example, I specifically talked about Kubernetes, but we could do the same for Docker. We could do the same for standalone applications using our binary there.
Mm-hmm. There is one more question, which is about what is the performance overhead using it?
Yeah, that's a really good question. An answer that developers typically don't like is it depends, but it's very, very low single digits. So in terms of CPU overhead, we're talking low, 1 to 3% additional CPU consumption. In terms of memory, we're looking at about 50 megabytes of RAM. Again, depending on how chatty that application is, we could be on the top end of that 2 to 3%. And the top end of that 50 megs. The key takeaway there is all the calculation and analysis doesn't happen on the application side. We're essentially just collecting all the data that, the telemetry as we refer to it, in the application and then streaming it into the portal, which is where the real-time analysis occurs. So the burden or the overhead on the application is quite minimal since the processing is happening within the portal.
Thanks. Let's proceed and see if we
so
get more questions.
Yeah, no worries. So let's dig into kind of some of the specific types of alerts. So let's start with some of the runtime alerts. So here we can see that we've identified, again, these are things that really only DeepFactor can identify, given that we're monitoring the application from the inside out. So here, when you click on the runtime tab on the left-hand side, we're showing you all the alerts that were generated across all the components. And they're prioritized, and the customer has the ability to change the priority against the default rule set. But in the standard deployment, we've marked a process that's been running, a process identified as running as root as a P1. And we can see we've got a bunch of those across different components, the category that it maps to, and then how many times it actually occurred. So this is a high-level representation of the alert. But if I go ahead and click on any one of these alerts, I then start getting some more detailed information. So again, the alert screens will look similar, but they'll vary in the data that's presented back depending on the type of alert that was generated. So in this case, we identify that this was a process that was running as root. We identify that it was not only a security concern, but it was mapped to a compliance. So where did this actually happen? What were the compliance frameworks that it would have violated? So in this case, it would have been PCI DSS, as well as SOC 2 Type 2. And then we give you very detailed description and resolution. So in this case, it may be quite straightforward because it's just a process that's running as root. But if it was a different type of alert, which I'll show you here in a second, we would have a much more detailed resolution. So down at the bottom here, you can also see which those processes were. So in this case, there was a shell command as well as a Python command, the process ID that was associated to those when it was observed. And then on the right-hand side, you can take some actions. So you can go into the system and say, hey, I'm going to acknowledge this, or I'm going to report this as not an issue. We give you some quick information about which those processes were, the PIDs, etc. And then had you taken any action, that would show up in the activity tab here. And then you also have the ability from within the portal itself to log this as a JIRA ticket. So we'll take all the information that is shown about the alert, and then you can assign that to a particular project within JIRA, so the developer has some context when they see the ticket. So let me show you some more runtime alerts before we move into some dependencies. So I'm going to actually look at an application that's written in C here, and we'll look at some runtime events here. So again, in this, you can actually see that there was another process that was running as root, but there's some other cool alerts that are generated that really only Deepfactor can catch at the application runtime in development. So for example, this application made an outbound connection to a prohibited country. So you could set a list of countries that the application is allowed to make outbound connections to. Another alert would be, in this case, an attempt to connect to an IP address that wasn't previously resolved by DNS. So why is this bad? This is bad because oftentimes third-party dependencies will be compromised, and the malicious attackers will hard-code an IP address to connect to when that dependency is executed. So it's a good indicator of potential compromise of that actual dependency itself. But let me dig into some of the program, application-specific alerts. So here, I think I actually mentioned this one earlier, but we noticed that there was a deterministic random number generation API that was used. So what does this mean? So if I click in this, again, you'll notice that the alert looks very similar to before, but we present a little bit, varying information. So again, we tell you what the alert was, where did it exist, the compliance. But here in the description, you can see why this alert triggered and why it's bad to use a deterministic random number generation function. So you can read up on the specific type of alert, but then we actually tell you what the resolution is, right? To inform the developer to be able to remediate this code. So you can take a look at the stack trace, which is displayed here on the right-hand side, and we give you some suggestions that, maybe you should use something like SRAND or SRAND 48. So on the right-hand side, you can actually see the stack trace. Again, the really nice thing about Deepfactor is we haven't integrated into your SCM. We're observing the application at runtime. And in this case, it happens to be a C application. So we've uploaded the symbol table, which allows us to collect this stack trace. So if I look at the stack trace, I can actually help the developer pinpoint exactly where in their code they need to go to remediate this. So you can see here that this actual vulnerability exists within the HTTP service.c on line 31. And then just like before, towards the bottom, we actually tell you which API, which process, and which PID this belonged to. So I did want to point that out because there's quite a lot of different varying types of alerts within the runtime itself. But again, just because you only see a handful of alerts here, it doesn't mean that we're not watching against a lot of other activities. So within the runtime, actually within any of these sections, you can actually look at the alert rules that it's being mapped to. So here you can see, some of the ones that were actually triggered or generated alerts. But if we scroll through this list, we're also identifying or monitoring the things such as any programs that are executing from suspicious paths. Is there anything that's loading from, any library that's loading from a suspicious path? Is the application reading any sensitive files? Is the application trying to do any manipulation within particular directories? In this case, we're looking for var. Again, malicious or compromised applications or dependencies may try to clear out or clear their tracks within their log files. So again, we monitor against lots of different types of alerts. So jumping back into dependencies now. So similar to runtime, we actually break down the dependency-based alerts. So here we can see all the vulnerable dependencies that were tied to this application. So we'll give you, the CVE, what those dependencies are. So in this particular case, you can see here that there were 3 log4js, the particular version, which component they existed in. So not only do we give you the CVE number, the CVS version 3 and 2 score, but if you expand this, we actually give you some, or rather a lot more detail about that particular vulnerable dependency. So here you have a description, you can see the source, and then we link you out to various references as well. We have different representations of, so if you, these are the vulnerabilities that existed, these are the actual total dependencies. And then here you can also see things like, what was the license associated to that? So earlier I mentioned that we have the ability to track different types of licenses. Lots of organizations may want to track to see if their application contains any GPL code, for example. That may subject them to open sourcing that, that particular piece of software. So again, these are very configurable things by the customer, but we collect and make that information available to each and every developer that uses this platform. We also give you a tree representation. So in this case, you can see all the methods and classes that are being used and where those actual vulnerabilities exist. And then we also understand that developers may not be responsible for all the components. They may be responsible for certain parts of the application or certain components. So if they wanted to quickly take a look at how those dependencies, vulnerabilities existed across components, they could see. So for example, here we can see the balance reader had a total of 16 vulnerabilities that generated 25 alerts, and then they could specifically drill into the vulnerabilities as it pertained to this container. Now, if we hop over to the operating system package, the view will look very similar. So again, the CVE name, the OS packages that this particular CVE was triggered against, the detailed information around that CVE, and then if available, so for example, here we can see that this libexpat1 will provide you with the fixed version. So this is also very helpful to the developer or the DevOps team, because not only do we tell them that they have a vulnerable operating system package that's installed, but we'll tell them which version of that package or library this vulnerability has been remediated in. So in this case, in terms of the loaded libraries, we'll actually show you all the libraries that are being used by the application. So again, you can see where those vulnerabilities map directly to the exact library that was used within the application. And then similar information to what I showed on the dependency page. So things like the package name, the version, the license information, and the components. And then to round out our SCA, so the complete bill of materials. So these are very specific, to just the dependencies and operating system packages, but often you want to see a kind of cumulative or aggregated view of what the bill of materials look like. So here you can get a view into all the dependencies that made up this application. You can get a view into all the operating system packages. And then earlier we mentioned the listening ports. So again, since we have a dynamic bill of materials, you can identify all the ports that the application is listening on, any outbound connections that this application was making. So we give you, not only things like the IP address, but the hosts, etc. And then any observed URIs that the application exposes. So I mentioned this a little bit earlier. So if you recall, when I mentioned the DAS scanner, often the DAS scanner will only have access to what it's able to find via a crawl or what's provided to it via an API specification, for example. In our case, we're observing and collecting that telemetry. So when you execute the DAS scan, you can actually complement the additional set of URIs that Deepfactor has identified. And then as always, we actually break that down against all the components so you can get a view by component across your bill of materials. And then the final thing that I want to show is the DAST scan. So here we talked about the OWASP top 10 web application vulnerabilities. So here you get very familiar results. So for example, we scanned particular components. In this case, we scanned the front end. We can see that it had an anti cross-site request forgery token check, which it didn't pass. But if I click on this, we give you the very similar looking alert. Again, very detailed description, resolution, where this actually happened. So there's these gets of the particular URIs, the methods, the confidence level when it was scanned. But this time on the right-hand side, we actually give you the request and response. So if I click on this, you can actually see, and I can expand this if you want to get a bigger view, but you can see things like the request header, the response header, the response body. And then we take it a step further. So if the developer wants to actually simulate this on his or her endpoint, we actually give you the curl command. So they can simply come in here and copy this curl command to run this particular check themselves. So again, very detailed. I'm not going to go through every one of these alerts, but this scans very comprehensively. The one key takeaway is it's very seamless. Often, scanning an application, you have to overcome firewall rules, potential routing issues. In our case, since the application is already registered, it shows up as a web service, and you simply hit start scan, and it will give you some options to configure that scan. So you can do things like if you want it based on an AJAX crawler, for example, or based on an API specification, the depth of scan. You can even pass it things like the authentication, etc. And since we're monitoring that application, if we can intercept any tokens, we can actually capture those and complement the scan without you having to actually provide any authentication as well. So Niladri, with that, well, maybe I'll just touch on a couple of other quick things, right? So we do have some integrations out of the box. So as I mentioned earlier, we integrate seamlessly into continuous integration platforms such as GitLab, Jenkins, etc. Project management tools, identity providers. A lot of times developers or organizations say, hey, we already have an SCA tool or vendor of choice, and we want to use that particular vendor. You can connect those particular tools within Deepfactor. Then you can also configure things like notifications. Now, again, you may not see your particular integration listed here, but everything is available through API. We have a very rich documented API that allows configuration. So everything that I've shown you on the portal today in terms of alerts, integrations, notifications, that can all happen through API. So if you never wanted to sign into the portal, but consume these in a different manner or send those alerts to a different system, you certainly have the flexibility to be able to do that. And then I'll end with alert policies. So we ship with a bunch of policies by default, but you can customize each one of those alerts. So for example, I've taken a copy of the interpreted language policy here, for example, and I've created a very specific policy called Bank of Anthos that I'm applying to the Bank of Anthos application. And if I take a look at this policy, you can see those rules that I talked about earlier, right? So the behavior violations, and this is where you would tune or tweak those particular rules. So here you can see I can adjust things like the priority that would be assigned to an alert. I can enable or disable it. I can add additional parameters if it's a configurable rule, such as outbound countries that I don't want my application to talk to. But then we also have rules around process, around library. Maybe for some reason you're allowed, or your application is actually loading libraries from home and you don't want to flag on those, you can remove those. Or maybe you want to add additional paths, you can do such things within the policy refinement here. Earlier, I also mentioned we have the ability to monitor for particular types of licenses within applications. But another rule that we have, which is very useful, is if we detect an end-of-life operating system. So we can generate a flag to say, hey, you're using Alpine version 3.11, that's end of life. Maybe you want to consider upgrading that. And then in terms of the dependencies, this is where you can see the unwanted license. We already talked about the GPL. And then we have a lot of policies around system risk calls. So in terms of file system remote code execution, insecure file system usage. So again, all these are very flexible to be enabled or disabled. I think with that, Niladri, that wraps up the demo, but I am happy to take any questions that Andrew may not have already answered. Thank you, Andrew.
Yeah, so a couple of things here. I saw some of the questions that are coming up. And one of the things that is not answered yet is what CM integrations are supported.
Yeah, so today we don't have any connectors out of the box, but if you wanted to send any of the events or the data into a SIM, you would do that today via API, and we would be able to help with that integration. We are continually adding integration into popular tools. Today we don't have a connector built out of the box, but there's nothing preventing you from sending that to any SIM tool.
Thanks. And I wanted to add to the question that Niladri Mandal had sent, that Has it been tested for performance in constrained hardware systems, for example, edge computing, which Andrew had replied, saying not specifically, but it has been tested by QA teams running on local hardware. But one of the point which I want to add here is technology is one part of the thing, but what we need to look at is from the point of view of a business question. Today, any of these kind of adding more resource is not a big deal. It's not costly. It's not very expensive. And the point is that expense bigger, or is the vulnerability that we are not going to find out and lose if something bad happens, is that a bigger risk? That's a business question that needs to be asked, and we need to start thinking from that point of view.
Yeah, that's a really great point, right? So at what cost do you want to evaluate? And I will add a little bit to what Andrew mentioned around performance. So we actually, we do have a detailed performance matrix that'll help give you some guidance. There's no kind of silver answer to exactly what it would be, but we've done analysis across a variety of types of applications, a variety of different language stacks, and as well as variety of how noisy or chatty that application is. So we can certainly get you within a particular guideline, and then we also set limits to make sure that the application doesn't suffer because Deep Factor has started monitoring that application.
So thanks Dinesh, and also Andrew for your constant support from the back end, answering the questions. I just wanted to quickly highlight one thing, that if you want to come over to Playground on a pay-as-you-go model, where you can have the real experience of trying out the Deep Factor with your team, or any other things like chaos engineering, security chaos engineering, value stream management, threat modeling, application security orchestration and correlation, we have partners with whom we are providing all of these services in one platform. And finally, to get more knowledge about all of these things and more, we have the largest DevOps and SRE event from India called DevOps India Summit. And this year it is 26th August 2022 from 8 a.m. to 8 p.m. Register there, it's free. Share it among your friends and colleagues and circle, because there is awards, there is call for speaker nominations available, sponsorship opportunities available. Join us in this great event. And with this, I would like to thank all of you, unless you have some other questions. We have a few minutes left, around 6 minutes. So I can see, no, there's no other questions as of now. But if anybody still wants to ask a question, please go ahead. We have around 5 minutes.
And I'd like to thank you, Niladri, as well, for allowing Deep Factor to present your solution here.
Thank you. Thanks, everyone. Then, if there is no questions, we will stop here. And you will be able to get this particular recording, and you'll be able to view these when you want, again, free of cost, in the same place where you went, the playgrounddojo.com webinar section. Once this is ready, it will be there and you can watch it free. Okay, thanks everyone. Thanks Dinesh once again. Thanks Andrew, and thanks everyone who have participated. Thanks a lot.
Thank you. Have a good day.